Today we want to look at gas law. We'll state the laws and mention one other important thing. Boyle's law is the first one to be considered. Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. I repeat, Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. Now, can you repeat that after me? Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. Also, Boyle's law can also be restated as the volume of a fixed mass of gas is inversely proportional to the pressure, provided the temperature is kept constant. Charles' law. Charles' law states that the volume of a fixed mass of gas varies directly with the absolute temperature, provided the pressure remains constant. I repeat, Charles' law states that the volume of a fixed mass of gas varies directly with the absolute temperature, provided the pressure remains constant. Can you take that after me now? Charles' law states that the volume of a fixed mass of gas varies directly with the absolute temperature, provided the pressure remains constant. And don't forget, we have the general gas law, P1 V1 over T1 equals to P2 V2 over T2. Ideal gas equation, which is the one I've just stated, P1 V1 over T1 equals to P2 V2 over T2. And don't forget, when a substance or a gas is at STP, STP means standard temperature and pressure, and the values, you should also remember the values. Now let's go to Dalton's law of partial pressure. Dalton's law of partial pressure. Dalton's law of partial pressure states that in a mixture of gases which do not react chemically together, the total pressure of a mixture of gas or gases is equal to the sum of the partial pressure each gas will exert if it alone occupies the whole volume of the container at the same temperature. I repeat, Dalton's law of partial pressure states that in a mixture of gases which do not react chemically together, the total pressure of a mixture of gases is equal to the sum of the partial pressure each gas will exert if it is alone occupies the whole volume of the container at the same temperature. Gay-Lussac law of combining volumes. Gay-Lussac law of combining volumes. Gay-Lussac law states that the volume of a gas which takes part in a chemical reaction bears a simple whole number ratio to one another and to the volume of the product if gaseous when measured at constant temperature and pressure. I repeat, Gay-Lussac law states that the volume of gases which take part in a chemical reaction bears a simple whole number ratio to one another and to the volume of the product if gaseous when measured at constant temperature and pressure. Avogadro's law. Avogadro's law states that equal volume of all gases under the same condition of temperature and pressure contain equal number of molecules. Avogadro's law states that equal volumes of all gases under the same condition of temperature and pressure contain equal number of molecules. And that will take us to Avogadro's number or constants, which stand as 6.02 times 10 raised to the power 23. Avogadro's number or Avogadro's constant is 6.0 times 10 raised to the power 23. Graham's law of diffusion. Graham's law of diffusion states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Graham's law of diffusion states that at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Can you take that with me quickly? Graham's law of diffusion states that at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. to the square root of its density. Now let's go to acid, base, and salts. Acid, base, and salts. We'll just summarize this topic because it's very broad. What's an acid? An acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. I repeat, an acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. And this process is known as ionization. And we have different types of acid. We have organic acid. These are naturally occurring products in plant and animal, while inorganic are prepared from inorganic matters. Some examples of organic acid are ethanoic acid from vinegar, tartaric acid from grape, lactic acid from milk, citric acid from lime and lemon, amino acid from protein, fatty acid from fat and oil, ascorbic acid from vitamin C or orange. While inorganic acid are things like HCl, HNO3, H2SO4, and H2CO3. The strength of an acid is determined by the concentration of hydrogen ion in solution. Strong acid ionize completely in water to give hydrogen ion and anions. The concentration of hydrogen ion is very high in strong acid. Weak acid are only partially ionized in water with low concentration of hydrogen ions. So that is what we see in organic acid. Basicity of an acid. The basicity of an acid is the maximum number of hydrozonium ion which one molecule of acid is capable of producing in aqueous solution. I repeat. The basicity of an acid is the maximum number of hydrozonium ion which one molecule of the acid is capable of producing in aqueous solution. For instance, HCl will produce 1, and we call it monobasic. H2SO4 will produce 2 hydrogen ions. We call it dibasic. And H3PO4 will produce 3 hydrogen, and we call that tribasic. Physical properties of acid. Dilute acid have sour taste. Acid turn blue litmus paper red. The concentrated form of strong acid are very corrosive. And chemical properties. Acid react with metals. Acid react with base and alkali, and we call this neutralization reaction. Acid can react with thiazocarbonate to liberate carbon 4 oxide. And they can be produced in different ways. Acid can be produced in different ways. One, by the reaction between an acid and anhydride and water, and by direct combination of constituent elements in the presence of suitable catalyst. Acid can also be produced by displacement of weaker or more volatile acid from its salts by a stronger or less volatile acid. Uses of acid. They are used in the manufacture of fertilizer, dye, detergent, explosive, paint, soap, textile, drug, plastic, and other chemicals. They are also used in dissolving metals or to remove rust, in producing salts, soft drinks, and baking powder. They are used as food preservative and mild antiseptics or germicide. They are used in oil refineries, and they are used as drying agent, dehydrating agent, and oxidizing agents. Now let's go to base and alkali. Base and alkali. A base is a substance which will neutralize an acid to yield salt and water only, and they are basically oxide and hydroxide of metals. A soluble hydroxide is known as alkali. Any hydroxide that is soluble in water is known as alkali, such as NaOH and KOH. These are known as alkalis. Properties of base and alkali. Alkalis have a bitter taste. Alkali turn red litmus paper blue. They have soapy feeling or feels. Concentrated form of the two caustic alkalis, sodium hydroxide and potassium hydroxide, have a powerful corrosive action. Have a very corrosive and chemical property. They can react with acid to give us salt and water. They can react with ammonium salts, and the preparation for base now, of base or alkali. Preparation of base or alkali. Most metals combine directly with oxygen when heated to form basic oxides. Soluble oxides of metal dissolve in water to form alkalis. Soluble oxides in water of metal dissolve in water to form alkalis. Some metals react with water or steam to produce alkalis. Now let's look at the uses of base. Sodium hydroxide is used in the manufacture of paper, soap, dye, rayon from cellulose. Sodium hydroxide is also used for refining petroleum, production of chemicals, and as a drying agent. Potassium hydroxide is used in making shaving creams and soap and soft soap. Calcium hydroxide is used in the making of mortar, plastic of Paris, whitewash cements, and in sugar refining and neutralization of soil acidity. Ammonium hydroxide is used for bleaching cloths as a detergent and solvent for grease. Magnesium hydroxide is used as antacid in toothpaste and medical as a mild laxative. Treating sting. Bees' sting are said to be acidic. Hence, you can ease the pain with sodium hydrogen tricarbonate, a weak alkali. Wasp sting is also alkali. You can neutralize them with ethanoic acid or vinegar. Now let's look at measurement of acidity and alkalinity. The pH scale is a number scale from 0 to 14 used to measure the acidity and alkalinity of a solution. Now let's look at salts. The last part we're looking today is salt. Salt is a compound derived from an acid by replacing all or part of the ionizable hydrogen contained in the acid by a metallic or ammonium ion. I repeat, salt is a compound derived from an acid by replacing all or part of the ionizable hydrogen contained in the acid by a metallic or ammonium ion. I repeat, salt is a compound derived from an acid by replacing all or part of the ionizable hydrogen contained in the acid by a metallic or ammonium ion. Most salts are neutralization products of acid and base. Salt therefore consists of an aggregation of positively charged metallic or ammonium ion and negatively charged ion. Types of salt. There are 5 main types of salt, namely normal, acid, basic, double, and complex salts. Now let's look at them quickly. Normal salts are formed when all the replaceable hydrogen ions in an acid have been completely replaced by metallic ion. For instance, where we have HCl coming together with KOH to give us KCl plus H2O. We can have acid salts. Acid salts are formed when the replaceable hydrogen ions in the acid are only partially replaced by a metal. I repeat, acid salts are formed when the replaceable hydrogen ions in an acid are only partially replaced by a metal. Example is when H2SO4 comes together with sodium hydroxide to give us NaHSO4, which is an acid salt. Basic salts. Basic salts are formed when there is an insufficient supply of acid from the complete neutralization of the base. The basic salt contain hydroxide ion and have the property of a base. Double salt. Double salts occur when hot concentrated equimolar aqueous solution of 2 simple salts are mixed together in the ratio of their relative molecular masses and are allowed to cool. So complex salts contain complex ion. That is, ion consists of charged group of atoms, e.g., solution of ion 2 salts mixed with a solution of potassium cyanide, resulting in the formation of potassium hexacyanoferrate 2, which is a complex salt. So let's conclude by looking at the properties or uses of salt. Salt are used in the manufacture of many industrial, agricultural, and and consumer substance like chlorine gas, fertilizer, and laxative. They are also used as food preservative, drying agent, and antifreeze material. Sodium hydroxide is used in preservation of meat, fish, and other perishable goods, in soap making, and separate soap from glycerin, for lowering the freezing point of water in refrigerating system, and to melt ice in freezer, to recharge water softener and stabilize dirty road, as it helps to absorb and hold water. So these are some of the uses of these salts. Thank you. We'll see in the next class.